Last one is 14C, how to find the n value or sample size of the number of trials. Okay, so you got your formula and your goal is to find n. So what if I didn't give you n, I didn't tell you the number of trials, but I told you the probability, I told you the chance that you want, how, right? And really it's very much like what you've done in year 7. If you learn how to do the formula for, let's say, area of a rectangle, you'd say length times width, and you've been doing that to death. Right? And then you finally get to the last part of the question and they will say, find the length if the area is 42, right? You go backwards. So it's the same idea now. You've learned how to use binomial distribution formula and you've found the probability over and over and over. Now they're going to give you the probability and they say find n. Okay? So here we go. Let's have a look. I want you to read this example here. Whoops. Right there. Okay? The probability of winning a prize in a game of chance is 0.48. Okay, so all we know is winning, the chances of winning is 48%. Yeah. So now we know the chances of winning. Okay, so this is the probability of what you want. Probability of what you want is 0.48. The question is, what is the, and I want you to really read the questions because a lot of students get bogged out by the question. And it's not really hard if you really think about it. Break it apart. It says, what is the least, at least the smallest number of games? So what's the smallest number of games that you need to play to ensure that you get a probability of winning at least once or more than 0.95? See, when I read it all out like that, it's like, oh, I have no idea what you just said. Yeah? Let's break it apart. It just says, what is the least number of games that you have to play? Okay, so how many times do I have to play? The smallest number that I have to play. So that your n. So how many games do I have to play? Or how many trials do I have to do? So that the chances, so probability, the chances of me winning, okay, at least one or more. So probability of winning one or more is bigger than 95% chance. So if I really reword this whole thing, it's just saying, how many games do I have to play so that the chances of winning one or more games is more than 95%? I just want to know that 95% of the time I'm going to win more than 95% of the time I'm going to win one or more. How many games do I have to play? So if you reword it like that, that makes a lot of sense. So you're just saying, I want to win at least one or more, but I want 95% of the time that I am going to win one or more. So how many games do I have to play? That's literally what the question's asking. Does that make sense if you break it apart like that? Because if you can make sense of what the problem is, you can write it down. See, essentially, anyone see the, oh, so cool. I stuck it to the table and I didn't even know. Here we go. Okay, so the question you're saying is probability of winning at least one. So I can write that. Chances of winning at least one, where X represents winning. We already know the chance of winning. The chance of winning was 0.48, right? But I want to know how many times do I have to play. So N is what I'm questioning. Whoops. N is what I want. How many games do I have to play so that the chances of winning one or more is more than 95%. So how do you write more than 95%? More 0.95. How do we feel? Does that make sense? I've just summarized this whole entire line up here in this sentence. Okay, so I'm looking for probability of winning one or more to be bigger than 95. Another way of looking at that is I want 95% of the time that I win one or more games. Is that easy? Yeah? So how many games do I have to play? That's the question. How many games do I have to play to ensure that 95% of the time I win one or more? See how I just reworded the sentence so that it makes more sense rather than reading it the other way around? Okay? That's your goal when you're doing this SAC or the end of year exam. Your goal is to read what I just did. Okay, because once you get this, now we work. Now let's think about it. Probability of X greater than or equal to 1. The problem is you already don't know how many games there are. I mean, it could be more than one, so it means you can find X equals 1, you can find X equals 2, you can find X equals 3, And you can go all the way. We just don't know how many trials there are. So you can go on to infinity if you want. So that's a problem. What's a quicker way of summarizing instead of saying plus 1, plus 2, plus 3, plus 4, plus 5, plus 6? What's another way of representing the chances of one or more?
Series.
Well, yes, you could do that too, but something easier. Yeah. If you took the total probability, remember total probability has to equal to 1. So if I took 1, take away the chances of not what I don't want, this should give me all the chances of everything I want. True?
Yeah.
Okay, so what's the chance of what I don't want? So what I don't want is 0. True? Because I wanted to win 1 or more. So the one thing I don't want is don't lose. Okay? Don't lose. The chances of losing, I don't want that. So chance of winning is 0. So all I can say here is, I can, instead of writing that whole line before, I can say this now. I can say 1 take away the chances of x being 0 is actually the same, or is a replacement for this. If this is the chance of what I want, then get the total minus the chance of what I don't want. It's the same thing. True? I still have greater than. I have greater than. And this is still 0.95. True? This is nice. Why is this nice? Because I can work this one out. There's only one thing I need to work out. Whereas before, I had unlimited possibilities of things that I needed to solve. But this one I can. So now I can rearrange this and I can try to find the chances of this. Because in this it's going to have n. True? That's what we're trying to find. We're trying to find n before. In this, you have to use binomial. And in binomial, you're going to have to use n to find it. So n is somewhere in here. But let's rearrange everything to get this by itself first. Okay, so let's have a look. I've got 1 over here. If I want to remove 1, I would subtract 1 on both sides. I'm going to subtract 1 on both sides. So watch, I'm going to subtract 1 on both sides. Take away 1, take away 1. This cancels out. What's 0.95 take away 1? Good. Negative 0.05. Okay, and then over here I still have negative probability of x equals 0. Now I don't want the negative, so when I divide negative on both sides, very good. When you divide by negative, you have to switch the inequalities. So remember, you have to switch the inequalities. So here, the probability of x equals 0, instead of being greater than, it is now less than 0.05. Okay? And this is nice because I've isolated probability of x equals 0. And I know how to find probability of x equals 0 using a binomial formula from 14a. Okay, so 14a, combinations, n. I don't know how many trials I have, but I do know x. I want 0 of them. What's the chances of getting what I want? It was 0.48. Chances of winning, I want 0 of them. Chances of not getting what I want, so if it's 48% of getting what I want, then 52% chance of getting what I don't want, so 0.52. And I've got n minus 0. This has to be less than 0.05. You got yourself an inequality there. And this is what I mean in exam 1, and we'll give you something like this. And you are meant to know what n naught is. Because we already know what 0.48 to the power 0 is. That's 1. Cancel that one out. What's n naught? So if I had n trials and I want to choose none, how many different ways can I do that? 1. So this is 1, that's 1. So what you're really doing is you've got 0.52. 0.52 to the power of n has to be less than 0.05. Going back to logs and exponentials, this is a power base. How do I remove 0.52?
Log it to the base of 0.52 both sides, and then so you can start with n less than log 0.52 to 0.05.
Very good. Okay, and so here you can use a calculator. And that's what this exercise is about. You can use a calculator here. Alternatively, if it's in exam 1, usually at this point you can solve it. Usually they will give you a percentage that you can work with, like half. You can do half to the power of n and whatnot. Okay? But in our case, we can do log with a base 0.52, or if they in the exam, if they specifically say log base e, you can still do log base e on both sides. So if I did log base e of 0.52. Yes, she's here. There we go. Okay. If I did log e of 0.52, remember this is to the power of n, and there's one of our rules that we can do something with the n. What do? You can drop it down. Very good. Log rule number 3. You can drop the n down. So this really now becomes, I'm just going to rub this side off so we get a bit more space. But you're essentially saying n multiplied 2 log e of 0.52. Now if you log e on the left hand side, you also have to log e on the right hand side, which is 0.05. Now to get n by itself, you can divide both sides by log n, log e of 0.05 divided by log e of 0.52. Now I made a mistake already. Has anyone picked up where my error is? Where's the mistake? Here I did log e of both sides. I used the log rule, dropped down the n, which is over here, so n times log e of 0.52, and I divide both sides by log e of 0.52. That's my error already. I got wrong. I can simplify it later, but I already made a mistake. For that.
You have to flip the sign.
Why do I have to flip the sign?
Because you divide it.
Yes, because I'm dividing, but more specifically, what am I dividing? Log. This log is negative. Can someone explain to me why it's negative?
Because log is simply a rearrangement of a to the power of b to c, where 0.52 is c is less than 1, which means that it has to be a negative.
Okay. Very good description. When you're doing your log graphs, log of 1, log e of 1 is equal to 0. Anything between 0 and 1, log e of anything in between 0 and 1 is going to be a negative value. If you draw the graph, you'll see that it hits the x-axis at 1, so anything between 0 and 1, the y value is a negative. So, if you divide by negative, the sign should be changed. It should be flipped. Okay, so that right there should not be less than, but should be greater than. And then you calculate it. Okay? Then you can calculate the value on your calculator, but just be careful with your notations. Or if you want to be more careful, just calculate it first before you divide it. Okay? Do the values before you divide it. Just those little hidden things with logs, be careful with that. But that's a common problem to come up.
Why don't I just do base 0.52?
You can. You can.
Because then now like cancel out 1, and then log 0.52.
Yeah, and it would have been fine. It would have been fine. I was just saying that in the exam, usually they tell you to keep it base E or base 10, so that you match it. So they want to know that if you can do this skill. But you're right. You do 0.52 log base 0.52 on both sides, and that is currently smaller than 0.52. So still, you have to recognize that log 0.52 0.05 is going to be a negative number.
Yeah.
You don't use because you're dividing a positive value by a negative.
So
That's a negative.
negative.
Well, you're not looking for a negative probability, you're just saying number of n trials is less than.
Yes.
Some way should cancel that. As long as you that's 1 n. Yeah, so it depends on what log. Oh, but then it's 0.52.
But the logs cancel out.
Yeah.
So it'd be 0.05.
Yes. Which I don't know what that is. Let's test that out. Log.
Well, it would be the same as 5 divided by 52.
Positive number.
It's a positive number.
It's a positive number.
Yeah. So that will tell you the number of trials.
So it's not
So
negative.
then wait,
No, it's not negative.
Do you round up the child?
Do you round up the... Yeah, because they said more than... So the question they wanted you to get is more than 95%. So right up to 4.58.
That's not the answer.
You have to say 5 trials. 5 trials. Or is it 5 trials? Yeah, 5, at least 5 games. That's the smallest number that you can have. 4 won't be enough, but you want more than 95%. That's how you do it. Okay? All right, have a go with the next one if you want. Otherwise, that's it. That is essentially all you needed to understand how to do. And that's part B. That's for you to try. But that's it. That's it for calculate.
How would you simplify the last thing?
Last one.
Okay, go back to I had bad quality. How would you simplify that?
On a calculator or non-calc? Oh, that's as low as you can go.
Oh, really?
Yep. That's what I'm saying. In the exam, if they give it to you, it will be something that you cancel. I'm just going to stop the video.